let's do one more thing before we break. Let's give a little warning to you. Often, this is not because this is the best plot ever, and also these are a bit thin here on the board here. Let me just emphasize it a bit. You might see plots like this often in scientific literature, and also in papers, journals, usual newspapers, where you illustrate two means and then you give some error bars for each mean separately. And that's what I'm going to touch on now. This is confidence intervals for each of the two means separately. That is what I taught you 2 weeks ago. I have applied here twice. This is not what I have taught you today. That's the learning message here. There is a difference between doing two separate confidence intervals and then doing what I taught you today. And already now you should realize that what I taught you just now is the right way to compare two means. And generally speaking, looking at two separate confidence intervals like this is not the proper way to compare two means. We could elaborate in various ways. It's found in our book material also, so you can read the details. The point is, without going very deep into the proof here, it's not rocket science in any way, so let me just focus on the core part of it. Each of these two separate confidence intervals, they are basically standard deviations, right? It's plus minus 2 standard errors. That's roughly. That's how a confidence interval is constructed, by having two standard deviations from the mean. Do you remember Arthur Benjamin? Two standard deviations from the mean. And rules of variability goes for variances, not for standard deviations. That you were taught a rule that a variance of a sum or a variance of a difference is the sum of two variances. That's the rule that I refreshed to you here. And then I emphasize the wrong. We don't have a similar statement for the standard deviations. And just to make it very explicit, let us assume that the two standard errors are actually 3 and 4. Then the sum of these two are 7, but the real standard deviation is 5 due to the rule. The additivity goes on the squared scale. It's a bit like Pythagoras in Danish. So that should make us think about what we can and cannot use such a plot for. And my little example, which is the one we were studying, is the best example to show it explicitly to us. Because if you look at these ones, this is the example from the nurses that I'm showing you here, right? Look at these two confidence intervals. They actually overlap, right? So they're naive and very much used. There's been papers in Nature about this just a couple of years ago, so you're not the only one. And I'm sure probably many people out there still does this mistake because they didn't listen in the basic stats class. And then they never asked again. Be careful about that in your future. These two confidence intervals here I didn't do any mistakes. They actually overlap. What was the p-value that we just looked at a couple of times already? That was 0.008. Very strong evidence against equality. So for these data, they are not the same, but the confidence intervals nevertheless overlap. So thinking about overlapping confidence intervals is not a good way to think. It's a very natural way to think if you get such a plot thrown in your face. So that should also make you think about which plots you want to make. If you want to convey that these are different, this is not a good, it's not a wrong plot. If you just tell what it's showing to you, it is just not the plot to emphasize the statistical difference between the two means. That's not what this plot is good at. So, the conclusion is on that, when they overlap, basically, we don't really know. You could teach yourself this finger more, the feeling of where's the limit then. If they just overlap a little bit, well, probably they're different. You can sort of teach yourself this sense of where the limits then are. That requires a bit of experience, or reading the right papers that giving you this inference by eye experience. Or just say we don't know. But however, it's clear that if they do not overlap, right? If I have a clear distinction, then it's okay. Then you can say they're definitely different, because the arrow goes the other way in a way, right? So if they really overlap, definitely. If they really don't overlap, definitely they are different. If they do overlap, you don't really know. That's the conclusion. And one more question before the break. Shouldn't have that long a memory to be able to answer this. Here we are. I just said that. I would accept they don't overlap, so we don't know. That's the general rule. But then I also indicated you could have a little bit of experience, and then by seeing someone that hardly just overlap a little bit, then probably they're different. Right. So that's what I gave you. And I seem to have a tendency, I can see, to choose the blue and the green one. I'll change that, of course, for the future. Let's see how it goes before we break. We have a new winner, or first Mel or Mike. I will, yeah. I'm gonna just ignore whatever stupid names you guys are using there. Anyway, let's break. Start again 15 minutes from now.